Okay, so as promised, this is 6.3 for question 6, right? What are we given here? A function h is given, excuse me. So function h, we are given this, and we are told that it has a minimum of 12 if x is equal to 2. We have to find the values of a and b. So this is what you do. Normally, when they say minimum or maximum, you know very well that they are talking of a specific value of y if you have a specific value of x, right? Basically, the turning point of x will give you the maximum or the minimum value of y. For example, here, I don't know the graph of this. We can't really say it's a parabola because this is b over x, so it just changes. Maybe it's a cubic function. I don't know. But we know very well that when they say has a minimum value, you're going to use your x being equal to 2 to find the minimum value. Anyways, let's just get down to it. So we're having h of x is equals to ax squared plus b over x, right? And you're told that the minimum value is 12. So what they're saying is 12 is actually h of x is equals to. So for us to get this 12, we used this x is equals to 2. That's what it means. So meaning where there's x, we're just going to substitute 2. So it's going to be a into 2 squared plus b over 2. So it's 12 is equals to 4a plus b over 2. So this is your first equation. Let me write it here. 12 plus 12, sorry, why am I writing plus? Let me write it in different color. So it's 12 is equals to 4a plus b over 2 is our equation 1. Please note that down. Now let's find the second equation. So they're talking of minimum. You know, when you say minimum, maximum, or a rate, whatever it is, you derive, right? Let's derive. We have h of x is equals to ax squared plus b over x, right? So let's first take this one up to be able to derive. So it's h of x is equals to ax squared plus b to the x to the power of minus 1. And the derivative is equals to 2. We drop the 2. A is still there. X to the power of 2 minus 1. And then we drop the negative 1, so it's minus b. X to the power of minus 1, right? So h prime of x is equals to 2ax minus b to the bx to the power of minus 2, like this. So if derived, remember when you derive, you equate this to 0. So 0 is equals to 2ax minus bx minus 2. So the x is actually this 2 here. Why? Because it's the x value of the minimum value. X value of the minimum value. So it's going to be 0 is equals to 2a into 2 minus b into 2 to the power of minus 2, like this. So 0 is equals to 4a minus b into 2 to the power of minus 2, right? So it's 0 is equals to 4a minus b over 4, right? So that's our equation 2. So which is 0 is equals to 4a minus b over 4. It's my equation 2. Now let's find the value of a and b. We have our two equations, so we're just going to use simultaneous equations. So you'll never run away from simultaneous equations. So now let's create equation 3. We can use any here. I'm just going to use the first. Actually, let me use the second equation to create equation 3. So we're going to have 4a is equals to b over 4. I just took this to the other side. And then I divide by 4. So therefore my a is equals to b over 16. So this is equation 3. So you're just going to say substitute equation 3 into equation 1 because we haven't used equation 1. So equation 1 is 12 is equals to 4. Where there's a, I put b over 16 plus b over 2, right? This is the equation I'm using. So it's 12 is equals to 4 goes how many times into 16? It goes 4 times. So it's b over 4 plus b over 2. So you can combine these two with your calculator. 1 over 4 plus 1 over 2. What are you getting? 1 over 4 plus 1 over 2. You're going to get minus b over 4, right? Cross multiply, you have minus b is equals to 48. B is equals to minus 48. So this is the value of b. Now I want the value of a, right? Remember, a is equals to b over 16. And my b is minus 48 over 16. So my a value, it's minus 3. So I got my a and my b value. Now let's get down to another question, which is question 7, which looks more interesting. Yeah, please check it out on another video. It's in the description of this specific video.